This video tutorial looks at the mathematical strand of linear and nonlinear relationships, and more specifically we're going to focus our understanding on exponential functions. So what is an exponential function? Well, essentially an exponential function is one where the variable is part of the index or the exponent. So as an example, we've got y equals 2x here, where you can see the x variable is the index. Alright, and you can see that instead of having a straight line graph or a hyperbola graph similar to a quadratic, we have a graph that simply starts out quite horizontal, but as we move along the vertical axis, the horizontal axes, we cross over the y-axis at the y-intercept, and then it takes a sharp incline and heads sort of straight up. Okay, so how can we graph exponential functions? Well, essentially we can use a table of values similar to what we did when we had linear relationships. All right, so we find our formula of y equals 2x, or f of x equals 2x, similar to what's shown here. We put our values into a table. We substitute our x value in until we can get our y value, and you can see on the graph here, all right, the blue dots where we've got our coordinates, or a set of coordinates. And here obviously we have our y-intercept where x equals 0, and it's important to remember that anytime you have an index value of 0, so for example if we have y equals 2 to the power of x and x equals 0, we get y equals 2 to the power of 0. Anything to the power of 0 is always 1. Okay, so that's how we determine the y-intercept. Now, I'm not sure if you noticed, but on the last slide there was some information about a horizontal asymptote. Let's look at the graph of y equals 2x and y equals 2x plus 3. Okay, we've got them in our graph here. All right, so this one is green, and y equals 2x is our blue graph. Now, we can determine the y-intercept just by replacing x with a 0. So if we want to work out our blue y-intercept, we go y equals 2 to the power of 0, which equals 1, and you can see there's our y-intercept. If we're looking at the green, we've got y equals 2 to the power of 0 plus 3, which is 1 plus 3, which is 4, and again, there's our y-intercept. But if we're looking for our horizontal asymptote, essentially this is the horizontal line. So it's going to be a y equals, okay, y equals. It's a horizontal line where the graph gets closer and closer and closer and closer and closer to, but never actually touches. So if we're looking at the graph of y equals 2x, all right, we can see y equals 2x, the graph comes down and it gets really, really close to y equaling 0, but it never actually touches. So the x-axis of y equals 0. And you can see if we look at y equals 2x plus 3, that graph comes down, crosses at the 4, and gets really, 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 really close, but never actually crosses y equals 3. So therefore, our horizontal asymptote for y equals 2x plus 3 is y equals 3. So it's the line, or the horizontal line, that the graph gets very, 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 very close to, but never actually touches. Okay, so let's have a look at some example questions. The first bit says, identify if the following are exponential functions. Remember, an exponential function is where the x, or the variable, is in the indice or the index or the exponent. Okay, so here the x is the base number, so this is not an exponential function. In our b, we have 3 to the power of x. X is the index, so yes, this is an exponential function. And in our c, we've got 3 to the power of 1 over x. The x variable is still part of the index, so yes. Second part says, identify the horizontal asymptote of the following. In our first graph here, we can see that the red line gets very, very close to y equals minus 2, but it never actually touches. So therefore, our horizontal asymptote in A is y equals minus 2. And in B, it gets very close to this line going along here, which is actually y equals 1. So therefore, our horizontal asymptote of our second graph is y equals 1. Okay, so here is a practice question for you to attempt. It says determine the horizontal asymptote and the y-intercept for the following. Please feel free to pause the video. Once you think you've got the correct answer, continue the video and we'll see how you went. Okay, so let's see how you went. The horizontal asymptote is basically this line along here, because the graph is getting closer and closer and closer, but it never actually touches. So this is y equals 3. So the horizontal asymptote is y equals 3. The y-intercept is when x equals 0. Now you can see on the graph that it's going to be 4, but if we want to do that algebraically, we end up with y equaling 2 to the power of 0 plus 3, which equals 1 plus 3, which gives us an answer of 4.